Okay, how did you go with that? Get yourself tied in knots? I'm sure you probably did. I know I did when I first tried to do this kind of thing. It does get a little bit hairy. But the solution, when you see it, isn't actually that complex. In fact, it seems to be, by my way of thinking, even simpler code than we had before. Not more correct, just simpler. Let's go and have a look at that. Okay, here's the project again. We did make some changes to database.h. Let's have a look at those. Where were the changes? From memory, they're right down here. Actually, the only changes are that now open file and save file take different parameters. Instead of a pointer to a CD, it is now a pointer to a CD, and the same here. Those are the only changes, and those are both in file.c. So this file didn't really change, but file.c did change. Let's have a look at main.c before we have a look at file.c. Okay, this is main.c. What do we notice? First of all, max CDs has come back. We need 100 CDs, so we've got that in there. Now, this is our array now. It is an array. It's certainly an array of 100 things, and each one of those things is a pointer. Each one of those things is a pointer to a CD structure. So it's 100 pointers. Again, we've got a count and a changes, and all of that stuff stays the same. Reset everything needs to change a little bit, because we have to individually free each CD. So, depending on how many we've got in our list, free each one. Obviously we only do that if there are some to free. In fact, we don't even need to do that count test anymore. We can simply do it like this. Because if count is 0, then we would simply never go into the loop in the first place. So it would look like this. Okay, got there eventually. So the loop wouldn't even run once if count was 0. But notice that each one of these elements of the array is in itself a pointer, and it can thus be passed to the free program, the free function. Are you sure it doesn't change? File new doesn't change. General open will change. Only a little. It's got its own temporary array of pointers now, and it works pretty much the same way as it worked before. We go to open file and read the new array in from open file. We'll have a look at open file in a moment. And if that succeeded, then we reset everything, which frees up the original list, removes everything from the original list if there was something. Set the new count. Now we need to actually copy the entire set of pointers from one array to another. In other words, we need to copy an entire array. Just copy all the pointers. We don't need to copy the things that the pointers point to. We just need to copy the pointers themselves. I know that's a little bit of a tricky one. That's probably the most difficult line of code to understand in the entire program. Why are we copying just the pointers here? Surely we should be copying the things that the pointers point to, in other words the CDs. Well, no, we don't need to. The CDs have been malloced and they're sitting in memory in various places scattered around memory, and we have a collection of pointers all in a line, an array of pointers that point to those various areas of memory where the CDs are. All we need to do is create a second collection, if you like. This will be the second collection of the second array of pointers that point to those same memory locations. So we use memcopy to do that. Memcopy is the best way to copy an array. You can use a for loop if you want to achieve exactly the same purpose, as long as you make sure that you're copying pointers, you're not copying the contents of the pointers. Okay, let's move on. Okay, that doesn't change. General save. This will not change very much. Changes just a tiny bit, because this, well, I don't think this changed at all. This, we have to pass in the CDs, and the CDs are right there. Now it's a pointer to a pointer rather than just a pointer, but it is passed in just the same. And so no, we don't actually need to change anything. And that doesn't change, none of that changes. Okay. When we're creating a new CD, we have to do something slightly different. The next element of the array, in other words, the next pointer, has to be set to do this. Now, all that's a very, very simple little function. That it's in utils.c. All it does is it calls malloc. and asks for 1 CD's worth of data, or 1 CD memory area, and if it fails it just exits the program with an error message. That's all it does. So we assign the value that it gives us, which is the value that it gets directly from malloc, into one of the elements of our array, and each element of our array is a pointer. And then we say, right, the contents of that pointer now is this CD. In other words, we do a structure copy and we increment the count. Okay, so that changed a little bit, and the display is not very different. The only thing that's changed is this. It used to require us to take the address of it so that we could get a pointer out of it, but now it's a pointer in its own right. So there's a little minor change there, very minor, and display all has got an absolutely identical change right there, very minor again, and quit doesn't change, display menu doesn't change, none of this changes, and that's it. So all we need to do now is look at utils.c for that very small function, the allocate 1 CD function, and then file.c, and then it's very, very simple. Here's utils.c. Like I said to you, the function in here is very, very simple. Allocate 1 CD. You pass it no parameters, and it will give you back a pointer to a new allocated CD structure. So we simply ask for that many bytes of memory. Notice that is the size of the contents of the pointer, not the size of the pointer itself. Even if the pointer doesn't yet point to anything, this expression, size of the contents of the pointer, will still be valid. Believe me, that's true. And it just simply prints an error message if it couldn't do the malloc, exit the program, otherwise it just returns the value that it got from malloc. Okay, let's finally have a look at file.c. Now this has changed a little in the sense that we are now dealing with a pointer to a pointer here, or if you like, an array of pointers. You could write it either way and it'll work exactly the same. Open the text file, that's all the same, and now we are simply writing that piece of information. That is a pointer. Now we used to have to take the address of that, and that is the size of the contents of one of those. Okay, so that's a very small change, very, very small, not much change there at all. An open file is very similar small change, and this here is very similar to when you actually created 1 CD. We simply allocate the space for 1 CD and assign that to the next spot in the array. That expression that's highlighted there is a pointer, and then we say, right, the contents of that pointer, the contents of that expression from the previous line is copied from the temporary variable called CD. It's a little structure copy. Okay, so that's all there is to that. The changes weren't that significant. I mean, they weren't that complicated if you fully understand pointers to pointers. And now I'm guessing that most of you don't fully understand pointers to pointers, so you probably would have had a little bit of trouble with that. So I encourage you to go back and pore over my source code, trying to convince yourself that you know exactly what's going on. The way to do that is to say, okay, there is an expression. What does that evaluate to? New CDs is an array of pointers, so one of those elements must be an individual pointer, and go on like that. That's the sort of way you have to convince yourself that this stuff works, is to read it in English like that, if you like. Okay, so that's the chapter on pointers to pointers. We've got one chapter left, that's called function